We'll have a look at a short question here. It's 2013 question A3. So this is a short question relating to our intersection of solids or our interpenetration questions. Okay, so obviously a question like this, you should be looking to get it done in your 10 minutes or that, probably even less. Okay, so the image below shows a sign outside the offices of a company called Key Technologies. In the sign, a truncated copper pyramid is intersected by a triangular steel prism. So there's a copper pyramid, there's a triangular steel prism. We can see it there cutting in through it and coming back out here. So the drawing on the right shows the elevation and incomplete plan of the solids which penetrate each other. Complete the plan showing all lines of interpenetration. And then it tells in this one to use a section plane to find the crossover points on the edge DE. Okay, so on that edge DE, take me t square out of the way. So that's our edge DE. So it wants me to use a section plane, which basically is going to be a horizontal cutting plane to locate points on my edge DE. The image below shows a keyhole logo. You can basically ignore that keyhole logo. That's not going to come into play. And then determine the true shape of triangle ABC. So this really is kind of a junior cert thing, really, the true shape of your triangle ABC. But anyway, it comes up. So we'll just have a look at that there now first. So the points in the front of the object on the right hand side of it, they're probably the handiest ones. Okay, basically with that, it's just a matter really of dropping from our elevation, dropping down into plan, and that will locate points for us. So our first edge here, so that top edge cutting through it. Okay, so what I'm going to locate first is, we'll say, this point here. Okay, we can see it clearly there in my elevation. That's an edge view of that surface and elevation. So that's where it cuts into it. So I can just drop that straight down and extend my line in my plan. Okay, so that's that point there now. Okay, so there's not a whole pile involved in finding that. Okay, so just going over it again, we just drop it straight down from our elevation, extend this in plan, and that's the point found. So we want to find out now where about that travels down to. So basically we're looking for this point here now. Okay, and it's going to be the same on both sides. So it's that point of our object we're looking for. Again, that's an edge view of our flat of our surface. So we can just drop this straight down again. Okay, and extend those ones again in plan. And wherever it touches, that's it. Now this is similar enough to some of the ordinary level long questions that would be asked. Okay, so it's just a short question here from the higher level paper. And join that up there. And we can join that down there. That's all seen, that's all solid. And when you're looking down top, you can see that line and the one that will be on the other side. So that's that there. So, and now this obviously goes all the way across, kind of to the triangle at the other side. It goes all the way across the bottom of our face. So that there will be dotted all the way across. Okay, so that will be a dotted line there. So there are all the points basically taken care of on that right hand side. I'm going to go over to the left hand side now and look at those ones. So again, if we look at our bottom edge of our triangular prism, so the bottom face of it, if you like. Okay, again, this is a face on our copper pyramid. That's an edge view of that face. So this point can just be dropped straight down, and these lines here then can be extended to meet that. So I'm just going to drop that straight down. That's where it crashes into that face. Drop that straight down and extend the ones then in my plan to meet that. Okay, and now the top point then, slightly different because it cuts in here. We can see it there cutting into the roof of it, if you like, okay, or the top of that copper pyramid. So I can drop that straight down anyway. Okay, so that's the top line there, so I can just extend that on until it hits there. And once it gets to that point, then it kind of disappears down into the pyramid and it comes back out there at that point. Okay, now They want us to use a section plane to find the crossover points on the edge DE. So basically what this section plane is, it's a horizontal cutting plane really. Okay, so I'm just going to get a colouring pencil there. I'm going to use red. Okay, let's get my red colouring pencil. And I'm going to put in a horizontal cutting plane, cutting through my object there. Okay, so that's my horizontal cutting plane, or my section plane as they after calling it. Now, I know that hits this point here, and it also cuts the back of that triangle there. So I can just drop that down and locate those 2 points there in plan. So drop that straight down. Sorry, get my pencil. Drop it down. It locates my points in plan, both here and here. Now, so that's 1 point on the cutting plane, that's another point in the cutting plane, and I'm all after determining it's all across that face there. So that's going to be another point on the cutting plane. So 3 points to find the plane. Because I have it in red in elevation, I'm going to put it in red in plan as well. So that's my cutting plane in there in my plan. Okay, so all that section there, that's showing my cutting plane. That area there, which is defined up here in my elevation of this. So that basically goes on forever, I suppose. Okay, to infinity or whatever. Now, where does that cross the edge D and E? Obviously here, and it'll cross here. So just extend edge D and E. So we have it here, and we also have our point here. Okay, so to finish off that drawing then, I need to join this up to that. Okay, and we do the same at the other side. So that's the line that triangular prism makes on that face of the copper pyramid. Those 2 lines there, it's kind of the opposite of that one there. Okay, and it has to finish, it runs along the roof it again. So this little bit here, run along the roof. To there and to there. So it'll be following that horizontal cutting plane, because that slices straight across the roof of our object. We just finish that off at the back there. Okay, so that's not even 8 minutes in getting that done, along with talking about it and all the rest. Okay, now there is actually a dotted line to go across there, just looking at it. So this line here going across will be dotted, goes on one side, the other the same basically as this guy here. Okay, so that's the dotted line there going across. So that's showing all that, everything I'm asked for. Now, determine the true shape of the triangle ABC. So where's the triangle ABC first? There it is. So that's my triangle ABC. So there's a couple of ways of determining the true shape of it. And I could go and get an auxiliary plan, looking flat at it here. So that's, let's say that's C, and A and B, A and B. I could get an auxiliary plan, take an X1, Y1, a new one, get a new view of it over here, get your distances here, plonk them on. That's it, you're going to get your true shape. There's a handier way though, because this is a true length. Alright, so that line there is a true length. So let's call it TL. Alright, that's a true length. It's a point view here. It's a true length in plan. What I can do is I can just swing it down over that line, swing it over here. So I'm basically rabatting, knocking it down flat onto the ground and dropping it down. So that's what I'm going to do. So I'm just going to first of all extend my XY. So extend my XY, get my compass, point on my true length, which is that point there, the point of the compass. I'm hinging or rotating around that, if you like, all the way down till it hits the ground. So now my point C is there. Drop that down to plan. AB is staying where it is. C is the one that's after folding out. So bring C out to there. So that now gives me a true shape of my triangle ABC. Okay, by using my rabattlement method, rabatting around the line AB. Okay, so that's all that there is in that question there. So look, you'd knock that out of the way in less than 5 minutes probably.